Lecture 14, Personal Library Management. In all the work that we've done thus far in all the previous sessions, all the material that you've developed during a session was lost, destroyed at the time that you signed off. The only material that you've been able to get back has been 10 class, and if you recall, you also got the stored material in one Apple course, the drill, the exercise that we gave you. Now, in this lecture, we're going to go through a series of exercises so that you can save material from one session to another, so that when you sign off at the close of one day, your work is preserved. When you come back on the next day, you have access to that work and don't have to type everything in all over again. If it's going to be relatively important that you stay pretty close to the sequence that I'm going to go through now in order to get continuity. If you'll please enter a right parenthesis clear. We get the response new workspace. Right parenthesis clear is one of a family of system commands. All system commands in the APL system start with a right parenthesis. We've seen quite a few. In fact, your sign-on number is a system command. When you type right parenthesis clear, you get a new workspace, and all the material that you may have had access to is now gone. We can demonstrate this by exercising yet another system command, namely right paren FNS, which gives the listing of the functions. We find no functions. Right paren VARS, which gives a listing of the variables. So we have a clear workspace. Now let's define a couple of functions, let's define a couple of variables, then demonstrate how we can save these functions and variables in order to get them back at some later time. Let's pick for our first function to define our old friend the hypotenuse. Del R is specified by A height B, and it's only a one-line function. R is specified by paren A raised to the second power plus B raised to the second power, whole thing raised to the 0.5 power, and we can type the del on the same line. Now let's take a look at the listing of functions. Typing right paren FNS gives you only the name hype. Let's set a couple of variables now. Let pi be 3.14159. And let's build a vector v composed of, say, the integers 1 through 5, 1, 2, 3, 4, 5. Ask for a listing of variables. And that list has pi and v in it. Next, let's define yet one more function. This time let's pick a very simple one, a simulation of the toss of a coin. We'll call it toss, del toss. I'll make it a nil-adic function which does not return an explicit result, striking the carriage return. Line 1 is simply question mark 2, and we can type the del now on this line. Now if we ask for a list of functions, we find we have hype and toss. Now let's pretend that we were going to terminate the session now, but that we want to have access to the functions hype and toss and the variables pi and v when we come back on. So we want a way to save the material that we have currently. The system command save, it's done by typing a right parenthesis and a SAVE and then a space, and then the name of what you want to call all this saved material. Everything that was in your workspace, namely all the variables and all the functions, will be saved. It remains only for us to think up a name under which we're going to save it. Now, almost any name will do, but I would suggest that you use the name first, FIRST, so that we can keep close in this lecture. I get the response first saved, the date. In your case, it'll be today's date and the time at which it was saved in terms of hours, minutes, and seconds, which should be the current time. Now, the material that we had access to has been saved, but it's really a little different from just having been saved. What we've done is take the image of the material that we had access to, as though we took a photograph of all of it, and put it away somewhere in a pigeonhole, if you will, called first. And now there's another system command which will give us a listing of the pigeonholes that we have filled with material. And that system command is live. If you'll type right parenthesis LID, we have the entry first, and then the message end of library. We also still have access to all the functions and all the variables that we set, namely typing right paren FNS of hype and toss. Now let's clear. Type a right parenthesis clear. We have a new workspace now. Let's see what functions we have. We have none. Let's see what variables we have. We have none. Can we get back the material that we saved? Yes, we can, and that we do by a right parenthesis load and the name under which we saved it, which was first. We get the message back that first was saved, and now if we type right paren FNS, there's hype and toss, and right paren VARS, there's our pi and v. And let's just check the value of v to see if it's what it's supposed to be, and we observe that it is. Now, it is very often the case that you may have a couple of areas of work, 2, 3, maybe more areas of work that you want to save in completely different areas. Let's clear again, and then define a couple of more functions and save them in some place other than first. Of course, the name we pick is going to be second in this case. So let's do another clear. We have a new workspace, no functions, no variables in it. Let's define the square root function again. R is specified by SQRT of x. R is specified by x raised to the 0.5, and we can type a del. Now we know that in this active workspace, or the environment that we're working in, we have a single function called SQRT. Let's pretend that we had several functions now, and let's save this material in a place called second. What do we have immediate access to at this point? We have immediate access to a workspace which is the one from which the image of second was taken. That is, the only function that we have, if I display functions, is SQRT. Suppose now that I want to get the material that I saved in first. Well, I can load first. Now the functions in my active workspace are hype and toss. Now I'll load second. Note that I didn't have to do a clear in between. Now the function that I have available is SQRT. Let's save yet another workspace. Let's do another clear. This time, let's load 10 class and save that in a place called third. We loaded it from 10 class. It's now in this active workspace Everything that was in 10 class, we took a copy of 10 class, we didn't take the original 10 class, is in this active workspace. If we type right paren FNS, we're going to get that lengthy list of functions that I've provided. You can suspend this typing, of course, by depressing the attention button on those machines that have the interrupt feature. I've depressed the attention button. Now, I can save this material in a place called, say, third. Now, if I type right paren LIB just to see all the various things that I've saved, we find we have a first, second, third, and an end of library. Let's clear again, define a couple of variables, and save that in a place called fourth. Clear. I'll let x be a 4 and a 6 and an 8 and a 10. I'll let y be a 2 and a 5 and an 8. And now I'm going to save in fourth. And now I get the message, save ration exceeded. I had only 3 workspaces available to me. Now, it's possible to acquire additional workspaces. It's possible that you have only 2 workspaces. That depends how your particular system is configured. So the save ration is exceeded. Well, let's pretend that x and y, which I have available to me now, are really much longer than they are, and I have to get them somewhere. I have to save them somewhere. Well, the first thing I'll ask then is which of the 3 available pigeonholes that I have can I sacrifice? Well, let's get a list of the library. First, second, third. Let's try to save it in third. We'll pretend that I don't need third anymore, and we'll try to save it in third. That's a right paren, save, third. You'd better be very certain that you don't need the material anymore before you do a save like this, because under some circumstances, third would have been erased. In this case, however, it's not saved. This workspace is iota 0. Iota 0 meaning clear or clean here. So we can't save it in third. Third already has something in it. Again, APL is preventing you from destroying previous information, because if we could have saved it into third, we would have destroyed the material that was already in third. It would have been replaced by what we had this time, namely the x and y. Well, suppose that we really want to get rid of third. How do we get rid of it? The system command drop. If you type a right parenthesis, drop, and the name of the saved workspace that you want to get rid of, which in our case is third, this will delete it from the library. This will delete all the material that was in third from the library, and then we'll be able to use that pigeonhole for other purposes. Third will now be dropped. And if we ask for right paren LIB, we have only first and second, and then the end of library. Now recall that that which we have access to, that is that which is in the active workspace, we don't have any functions, but we do have those 2 variables, x and y. Now let's save this material, but let's say that we don't want to call it third, we want to call it xy, as that is the 2 characters x and y placed together. Well, to demonstrate that we're not constrained to using the names first, second, third, and so forth, I'm going to type a right paren save space xy. And now, in my library, I have first, second, and xy saved. And I've already discovered that my library has the capacity for only 3 workspaces. But it doesn't matter what I call them. Now, APL is going to give you a lot of protection against destroying material that you have saved. Recall now that an image of X and an image of Y went into the workspace called XY. If I tried to save it into first, not saved because this workspace was most recently associated with the name XY. So if I wanted to save the material that's in my active workspace into first, I would have to drop first. Then I could call it first again with a save first, but the point is that unless it comes from that place, I can't save it there. But watch the following. I'm going to load first, add a function to that workspace, and then save it again. This I'll be permitted to do. Load first. It currently has these functions in it, height and toss. Let us define a sign function, S-I-G-N, a sign function, and add it to this. Now, what I've done thus far is to take an image of what's in the pigeonhole or the workspace, the saved workspace called first. I put it in the active workspace. I have an image of it. I'm going to add an additional function to that image, a function called sign. This is a monadic function which returns an explicit result. Del R is specified by sign of X. R is specified by, and again, that's X greater than 0, subtract X less than 0, and a del. Since it's a one-line function, I can close it out on that line. Now the functions that I have available in my active workspace are height, sign, and toss. If I attempt to save this into second, recall it came from first. It's not saved because it came from first, but I am permitted to save it into first. And now first has been updated, which we can demonstrate. Let's do a clear first. Now we have no functions. Then let's load first. And now the functions that we brought about are height, sign, and toss. So reviewing, you can save material that you have. You can save several types of material. The place where it's saved is called a saved workspace. You save all of what's in the active workspace at the time that you enter the save. You can recall material from the saved workspace into the active workspace. And what you get is the status of that workspace at the time that you saved it. It's as though no time had transpired whatsoever. Finally, you can delete a workspace. You can drop a workspace by typing right parenthesis drop and the workspace name. This concludes Lecture 14. Lecture 15, use of the public libraries, the copy command, and the workspace name to continue. In the last lecture, we showed you how you could save active workspaces by giving them a name and using the command save and that name. Let's check now by typing right-paren live to see if in fact that material is still there. Although we won't be using it any further, it's interesting just to check if you've lost your connection with APL since the last lecture. So typing right-paren lib obtains for us